Hello and welcome to Unit 1, Lesson 6. The learning target for this lesson is I can identify the differences of rational, irrational numbers, square roots, and cube roots by understanding the real number system. So the first questions we have is to use a calculator to solve for the square root. So you guys all have your graphing calculator. So in order to type in the square root, you're going to hit the second button and then hit the x squared button, because above the x squared you'll see the symbol. So you're going to hit second and then square root button, the x squared button, because above it is the square root. Then you will type in your answer and you should get 13. Same thing for the second question. Type the negative sign, then you hit the second x squared button to make the square root. Type in 64 and your answer is -8. Same thing here. You could type in the square root of 36, which is 6, divided by the square root of 225, which is 25. And when you type that into your calculator, you get 0.24 as your answer. So they're asking, what is a perfect square? A perfect square is the product of a number multiplied by itself. And so create a list of the perfect squares. The numbers that are multiplied are called your root. And the answer is your perfect square. So 1 times 1 equals 1. 2 times 2, 2 is your root, 4 is the perfect square. 3 times 3 is 9. So 3's are your roots and 9 is your perfect square. 4 times 4 are the root, 16 is the perfect square. And now we're going to fill in the rest of them. 5 times 5 is 25. 6 times 6 gives us the perfect square of 36. And you're going to go ahead and complete the rest of this page up until 20 times 20. Okay, so here we have the rest of our perfect squares. As you can see, all of the perfect squares are in the boxes. So just check your work with everything that is there. And if you need to pause it with the answers shown, go ahead and check your work. So the next slide we have is comparing square roots and cube roots. So a square root is of a number. The square root of a number is the number when multiplied by itself gives you the number. So you're multiplying the number by itself 2 times. And a cube root of a number is when you multiply a number by itself 3 times. So to find the square root of a number, again, you type it into your calculator and you click the second button, then the x squared, and then type in the number, and the square root of 9 is 3. And we see here that it's asking, what is the inverse of a square root? So like we've always have seen, the inverse of addition is subtraction. The inverse of multiplication is division. So the inverse of something squared, of the square root, is something squared. So when we want to get rid of a square root, you would square it and get rid of it. So in this case, if we want to square the root, is going to equal 9, because 3 squared is 9. 3 squared is 3 is 3 times 3. So that is what it means to square something, is multiplying by itself 2 times. So when you have this symbol with the 3 instead, over here it is a 2, but you just never have to write it because it's squared, meaning 2, and cubed means now 3. So to create that, in your calculator, you're going to go to the math button, then hit number 4, which will look like this. It will look like the symbol. And then hit enter. And then you can type in the number 8, and it will give you the cube root of 8, which is 2. And again, the opposite of a cube root, so the inverse of a cube root, is cubing a number. So 2 cubed is 2 times 2 times 2. The actual exponent here tells you how many times to multiply this number 2 by itself. So you're multiplying the number 2 by itself 3 times, because the exponent says to multiply it 3 times. Over here, it's being squared, so you multiply the number by itself 2 times, which is 3 times 3. And as you can see, when you take 2 cubed, it will equal 8, because 2 times 2 times 2 is 8. So on this page, the real number system is made up of all irrational and rational numbers. So this is all numbers except imaginary numbers. Now we're going to go through a couple of different numbers, or types of rational and irrational numbers, in order to distinguish them, their differences. Okay, so I have filled in for you the different type of rational numbers and irrational numbers. And then I'm going to type in some examples for you. So for integers, you could have negative numbers, 0, and positive numbers as well. So it's any number basically on a number line. So it could negative 100, 1,000, 600. So any integers are rational numbers. Perfect squares, all perfect squares are rational. So we have many different perfect squares. So we can say that the square root of 36 is a perfect square, since the square root of 36 equals 6. The square root of 121 is a perfect square because it equals 11. And 6 and 11 are both rational numbers. They are integers, and all integers are rational. Terminating decimals are decimals that end. So decimals that stop, so 0.2, 0.36, negative 0.578. As long as it ends and doesn't have the ... at the end, meaning that it's going on forever, it is a terminating decimal. All repeating decimals, so 0.33 with a line over it, 0.45 with a line over it. Anything that's repeating, so if you see the line over it, you know it's a repeating decimal. Those are rational numbers as well. And all fractions are rational as well. So we could have 1/2, we could have negative 6/7, negative 8/5. Any fraction is going to be rational. And the biggest hint is the minute you see a fraction, even if you aren't sure of the number it is, you just start saying to yourself, all rational numbers can be written as a fraction. So anytime you see a fraction, it is going to be a rational number. And all rational numbers can be written as a fraction, because if we look here, negative 2, if you want to make it into a fraction, always has 1 in the denominator. Same thing with the square root of 36 equals 6. 6 is over 1, which is a fraction. Terminating decimals. If you were to type them into your calculator, you would figure out what their fraction is. Okay, and even repeating decimals, 0.3 with a line over it is really 1/3. So all rational numbers can be written as a fraction. Now we have irrational numbers. Irrational numbers are pi. So if you ever see anything being added, subtracted, multiplied, or divided by pi, you know your answer is going to be irrational. Because that number, if you were to figure out the number, it is a non-terminating decimal that goes on forever. So that means it never ends, it doesn't repeat, it just is a very long decimal that does not end. All non-perfect squares, so the square root of 40, the square root of 98, anything that does not equal a perfect square. So if you were to type it into a calculator, it doesn't come out to a whole number. Therefore, that would be a non-perfect square, which are irrational numbers. Non-terminating decimals mean decimals that go on forever. So 0.653 dot, dot, dot. If you see those dot, dot, dots, that means it's going on infinitely and going to never end. So that is a non-terminating decimal. And same thing with non-repeating. It's just a decimal that has a bunch of random numbers. Again, 6, 5, 3, 7, 8, 9, and just keeps going forever. So non-terminating, non-repeating. Okay. Those are both irrational as well. Over here is just talking about rational numbers on a number line. In the middle is 0. 0 is neither positive or negative. We have our negative numbers go to the left side. They're less than 0. And the numbers are positive are to the right side, and those are greater than 0. Okay? So create a list of rational and irrational numbers and place them on the number line. So you can just pick 2. I'm going to pick 3.5 is right there. And I'm going to pick negative 3.6 is about there. Okay? This right here is just some vocabulary. Here we have our natural counting numbers. They start at 1. So it's like when you count something, you start with 1 and you just keep going up. 1, 2, 3, 4, 5. They're natural counting numbers. Whole numbers are natural counting numbers, but you start with 0 now. So every whole number is from 0 and up. So 0, 1, 2, 3, 4, 5. Positive and negative whole numbers are now that's your integers. It's including all numbers, positive and negative, and 0. Terminating decimals, we already went over, are decimals that don't end and they do not, decimals that end and they do not go on forever. So here's a bunch of different examples. Non-terminating decimals are decimals that go on forever. And usually you will see those dots at the ends, okay? A repeating decimal is a decimal that repeats itself and has a pattern. So here we see it's 821, 821, 821. In this one, the decimal 3 is repeating, and so forth. A non-repeating is a decimal with no patterns. Here we see 14159265. There's no pattern, so that is not repeating. Okay, is each number rational or irrational? And you justify your answer. So we'll do the first one together. The first one, this is how you will answer each one. The first question will be rational. And it's rational because it is an integer, right? Number 2, it is going to be rational because it's a terminating decimal. So this is how you will answer each one. Number 3, this one's a little bit tricky. So when you have an operation being performed, you kind of want to look at everything all together. So when you are multiplying a square root by another square root, you always keep the square root and multiply the 2 numbers inside. So I'm going to keep my square root, and 20 times 20, when you type that in your calculator, is 400. Now, you go and check what the square root of 400 is. So the square root of 400 is 20. And 20 is a rational number. So your final answer is what it's asking for. It's not asking if, like, if there is an operation to perform it first, get your answer, and then state whether that answer is rational or irrational. So 20 is rational because it's an integer again. Okay. For the next one, we have 1/4 plus the square root of 2. So the two ways you can look at this. You can say, okay, I know 1/4 is rational plus the square root of 2. Well, we know 1/4 is rational because it's a fraction. And right off the bat, we say fractions are rational. And now we have the square root of 2. If you type the square root of 2 into your calculator, you see it's a non-perfect square. And we know non-perfect squares are irrational. So a rational plus an irrational number equals an irrational number. And if you wanted to type that into your calculator, you will see that when you just type straight into your calculator 1/4 plus the square root of 2, you get this decimal that's non-repeating, non-terminating. And therefore, that is irrational. And you can say it's irrational because of the two reasons we have there. You can either say it's a non-terminating non-repeating decimal, and you could also say a rational number plus a irrational number equals an irrational number. Okay, so there we see that this answer is going to be irrational because it's a non-terminating, non-repeating decimal. Over here, again, we have some multiplication we need to do. 3 is an integer, so we know that's a rational number, times a square root of 64. When you type that into your calculator, you get 8. And 8, that means it's a perfect square. So again, that is a rational number. And when you multiply any two rational numbers, you will always get a rational number. So therefore, this is a rational number because if you were to type this into your calculator, 3 times the square root of 64 is 24, and 24 is an integer. Or again, you can just say a rational number times a rational number equals a rational number. And last but not least, here we have the square roots. So we have the square root of 10 times the square root of 5. So remember, we want to multiply the two numbers underneath the square root and keep the square root. So 10 times 5 is 50. And the square root of 50 is a non-terminating, non-repeating decimal, which is irrational because the square root of 50 is a non-perfect square. So we know that this answer would be irrational, and it's a non-perfect square. Okay, so when you type that into your calculator, you get a decimal that goes on and on and on forever. Okay, so we have our mid-lesson assessment. What is the best classification for -4? So let's just read through our answer choices. -4. A says it's an irrational number. That is not true, so I'm going to cross that out, and with that being said, I'm going to cross out A. We know -4 is a rational number. So we're going to just cross out anything else that possibly says irrational, but thankfully nothing else says that. It is an integer, it's a rational number, and it's a real number, yes. So B is still going to be in the running. It is a whole number? Whole numbers. That's anything from 0 and higher. So that does not include negative numbers. So -4 is not a whole number, so C is out. Now we have natural numbers and real numbers. Again, natural numbers now start with 1 and go up. They don't go into the negative numbers. So that is out as well. So D is out and B is out answer because -4 is an integer, it is a rational number, and it is a real number. Okay? So which of the following are irrational and why? We know 3 is rational because it is an integer. We know that 0.7 is rational as well because it's a terminating decimal. We know -0.225 is also rational because it's terminating. So these are rational. Now we have square root of 20. Square root of 20 is irrational. Yes, it is irrational because it is a non-perfect square. If you type that into the calculator, you do not get back a whole number or an integer. 4.5678 is rational, again, because it's a terminating decimal. And we have the square root of 25. That is rational because it is a perfect square. And we have, last but not least, 7.4 with a line over it. That line over it tells us it is a repeating decimal, which is rational. So the last reason, repeating decimal. Okay, so that is our reasonings for each of them. So the only one that was irrational and why was this square root of 20, because it's a non-perfect square. Okay, so for this one, the same way we answered the two slides before this, I want you to go through each one. And you're going to pause the video now, and when you come back, you're going to check your answers with it. So you're going to state whether it's irrational or rational and why. Please use the specific vocabulary. Go back to the checklist we made. Go back to the list that I made with you with examples, and make sure you're using the correct explanation and vocabulary. Okay, so please check your work with the answers. As you can see, we have our number 1 is rational and it's a repeating decimal. 2 is irrational because it's a non-perfect square. 3 is rational because it's a fraction. 4 is rational, it is an integer. 5, the square root of 16 is 4, and the denominator is 4, and 4 divided by 4 equals 1, so that is a rational number and it's an integer. 6 is rational because it's a terminating decimal. 7 is irrational because it's a non-terminating, non-repeating decimal. Same for 8 is rational, it's a terminating decimal. 9 is 15 1/3, it's rational, it's a fraction. 10 is irrational because it's a non-terminating, non-repeating decimal. And 11 and 12 are both irrational because they have pi in it, so they are non-terminating, non-repeating decimals. So now we are going to go through each statement and state whether it's true or false. And if it's false, we're going to say why and provide a counterexample. So for number 1, we have that all whole numbers are rational numbers. So if we think about it, our whole numbers are going to be 0, 1, 2, 3, etc. And it's true. All of those whole numbers are going to be rational. So that's we can write as true. So number 1 is true. Number 2, we have the square of a number is always greater than the number. So if we were to take the square of a number is always greater than the number. So if we take 2 squared equals 4, is 2 squared always greater than the number? What do you think? That would be true, because the square of a number is 4, is greater than the number, which is 2. So that's true. 3, all whole numbers are integers. Is that true? All whole numbers, again, are 0, 1, 2, 3. And are all of those integers? Yes, so that's true. No fractions are whole numbers. Is that true? That is false. Some fractions are whole numbers. So think of it. Whole numbers are like 2, 3, say even 50. 2 as a fraction is 2 over 1. 3 as a fraction is 3 over 1. 50 as a fraction is 50 over 1. So some fractions are whole numbers. So that would be false. 5, a natural number is a whole number. Natural numbers are counting numbers. So remember, that's like 1, 2, 3. Natural numbers do not include 0 or negative numbers. So is all natural numbers a whole number? No, because 0 is a whole number. So that's false. So we can come up with a counterexample for that one. Oh, I'm sorry. That one, I'm sorry. A natural number is also a whole number. That is true. That's just, I read too much into that one. But that is true. A natural number is also a whole number. Yes, because if you think of all of the natural numbers are also included in the whole numbers. So even though it's 0, it's 1, 2, 3, etc., which is every natural number. That's true. Any integer is a whole number. That's false. And a counterexample could be, not all integers are whole numbers. And an example, let's think, any integer is a whole number. Negative numbers, like -5, -100, etc. Okay? And back to this one, no fractions are whole numbers. The counterexample would be some fractions are whole numbers. And I just went through some of those examples with you. Okay. Number 7, every rational number is also an integer. Every rational number is also an integer. That is not true, because we know that 2.5, so this is false. We know, for example, 2.5. That is a rational number. but it's not an integer. So our counterexample can just be not every rational number is an integer. And as you can see, we have 2.5 and so forth. And number 8, every whole number is a natural number, integer, and a rational number. So we know whole numbers are 0, 1, 2, 3, etc. But natural numbers do not include 0. We know that every whole number is an integer, yes, true, but this part was false. And we know it's also rational is true. But the minute you do have this one false part, the whole statement is going to be false. Okay? So your statement is just going to be not every whole number is a natural number, integer, and rational number. So the last question for the exit slip says, it's from a Regents question. Which set of numbers would be the most appropriate set that predicts the number of households online devices in terms of the people in the household? So when you think of your counting online devices in a household, you're not going to count using rational numbers, right? Because we're using rational numbers. But do we count using fractions and decimals when we're talking about online devices? No, we're going to count as 1, 2, 3, 4, 5, 6. We're not going to have possibly 1.5 computers in the households because you can't have a half of a computer. So rational numbers are out. Now we're between integers and whole numbers. Now integers include negative numbers. So we have -2, -3, -1. Include 0 and all positive numbers. Okay, so again, our integers have negative numbers, 0, and positive numbers, and the whole numbers are 0, 1, 2, 3, 4. So when you think of the best way to count the number of household items in households, online devices in your household, you're going to use majority whole numbers. You're never going to count using negative numbers or 0. You're always going to count within the positives. So whole numbers is the best set of numbers to predict the number of households, online devices in terms of the number of people in your households. The next slides are just your checklist. So they're again just going through how to write the square root of a number in your calculator. So again, you hit the second button, then the squared button, and then hit the button enter with the numbers underneath it. And the next one also teaches you how to write the cube root into your calculator and then enter it. And then we get to the summary slide, and remember, please use this slide to write down anything important that helps you memorize the difference between rational and irrational numbers and any other tricks that you might find useful. All right? And this is the end of Unit 1, Lesson 6.